Waves of what? Now, that was my reaction the first time that someone tried to describe to me how a wave behaves inside of a tube, because I was trying to understand how my own voice works. And I found out that, well, my voice is basically, it's a tube, and that tube is a filter, and it's connected to a power source, and that's my lungs. And in between the two is this source that gets filtered to make my voice. And this source is my larynx. It's my voice box. And my voice is emitted from there and filtered by what comes after. Okay, great. But I wanted to know, how does this all work? What's resonating in there? And I was told about waves. And I thought, waves of what? So today, all I'm going to talk about is what are these waves? Now, the waves, to be clear, are sound. When we're talking about what's going on inside the vocal tract, what we're talking about is sound. Now, when we talk about frequency, what we mean is how often something is happening. In the case of waves, what we mean is how often the wave goes by. So if we're standing in place and waves are coming by and you got hit 400 times in 1 second, that's 400 hertz. When you take waves of anything, whether it's water or air, and you trap them inside of a container, you get different behavior than you would if the waves were just allowed to do whatever they want. That's called constraining a wave. And when we're talking about a vocal tract, the kind of constraint we have is a tube that's open at one end and closed at the other end. So we call that a closed tube. And just for reference, because this is good to know, whenever you have a closed tube, it's what we call a quarter length resonator. So that means when you take a wave and you fit it to the tube, or when you find a tube that perfectly fits this wave, your tube is going to be exactly 1/4 as long as the wave. When you have just the right relationship between a tube and a wave, you get this crazy effect that you probably remember from when you were a little kid taking a bath. When you're sitting in the bathtub, if you start to move back and forth, you make a wave. And if you time it just right, that wave starts to meet itself because it bounces off the bathtub and comes back. When that starts to happen at just the right rhythm, which is you making just the right frequency of wave, or in other words, just the right wavelength, you get something called a standing wave. Suddenly, the wave that you were making becomes really powerful. It's like it's out of control powerful, and your parents are going to be really mad because you make a huge mess. Now, you in the bathtub making a wave is actually the power source filter model. So the power was your muscles. The source was the wave that you initially created by moving back and forth. And the word for moving back and forth is oscillating. So by oscillating at a particular rhythm, you made waves of a particular frequency and therefore of a particular wavelength. Those waves were reduced a little bit by the filter, the bathtub, which is basically a closed tube. Well, not basically, it is a closed tube. The other waves, though, they were taken down a whole lot more than the waves that fit in your bathtub. And the result was all that energy needed to go somewhere. And it went into the waves that fit a lot more than it did into the waves that don't fit. These waves that fit lasted a long time, and the waves that don't fit, well, they kind of got destroyed the more this went on. And the wave that did fit became a standing wave that looks a whole lot more powerful than what you started. When our waves start standing still like this, well, now the frequency, instead of how often it's going by, is going to be how often it goes from being really tall, and then it becomes a really deep negative version of itself, and then all the way back. And just like in the bathtub, these waves are sloshing back and forth in your vocal tract. And that's how they're getting strong. Instead of water in the tub, we're exciting the air so much inside the vocal tract. You know, we make these pressure waves, and some of it gets pumped out. What's confusing sometimes is that at the same time as this is going on, we're very slowly exhaling. But a good thing to just imagine when you're trying to figure out how does the resonance thing work in the vocal tract is don't think about air flowing out. That's happening, but essentially it doesn't need to. So if we could make everything without having airflow, so just using artificial larynx, then we can get the same effect. It has nothing to do with this overall flow. Now, what we're talking about is a kind of pumping out of these bursts that are moving a whole lot faster than just this regular flow of air. And we're also talking about a whole lot less air. So we're talking about this very, very, very fast, very small vibration. Those are disturbing the air just in front of your mouth, and that disturbs the next air over, and so on, and that's what we hear. Now, next time, I'll talk about how these waves interact with the vocal tract, because the vocal tract is a little bit more complex than your bathtub. What's important to know for now is when you're talking about resonance inside the vocal tract, you're always talking about the whole thing from beginning to end. And the waves are sloshing back and forth. And as they do so, they do this standing wave behavior because of the filter effect of the vocal tract. And that's resonance. So even though we're drawing these waves kind of like squiggly lines, they look like they're bouncing around the vocal tract. That's just a way of showing where the standing waves are happening, where in the bathtub the mess is being made, where it's coming from. And when we're talking about the vocal tract, we're not just talking about making one of these. You know, you can make multiple standing waves at the same time. And just like in the bathtub, what the waves actually are like is just like the water is all crowded together. You know, when it's in the tall part of the wave, you think about all that, the water's all crowded together. And then when it's in the lowest part, it's just an opposite version of the same thing. So now instead of being really crowded, it's crowded with nothing. That's what's going on in the vocal tract. And that's kind of the magic of it and why we get these kind of powerful effects.